Hello and welcome to A Ramble with me. Today we are looking at the department's May 2022 paper 2, question 5.2. Determine the general solution of sine x cos x plus sine x is equal to 3 cos squared x plus 3 cos x. Okay, so things that immediately stand out for me when I see sine x cos x, I think sine of 2x is the same as 2 sine x cos x. Maybe there's an opportunity to use that. Let's see. But then the next term is sine x, and I see, well, okay, so there's a common factor. Who knows? And then next up on the other side, I see 3 cos squared x plus 3 cos x. The two threes, common factor, a cos x and another cos x here. So it's smelling like maybe if we try factorize each side of the equation, we'll have a bit of a clearer vision. So let's go ahead and do that. Otherwise, the fallback is going to be maybe there's something about double angle somewhere here, because the cos squared x also made me think double angle, cos of 2x is cos squared x minus sine squared x, so maybe not quite, but who knows, maybe, I don't know. But yeah, it feels like factorizing is more promising, so I'm just going to start with that and see where it lands us. So if I factor out sine x, from my first term, I'll be left with cos x. From my second term, I'll be left with 1. Then on this side, we have a common 3 cos x. And in the first term, we'll just be left with cos x. And in the second term, we'll be left with 1. And would you look at that? Both sides of the equation then have a common factor of cos x plus 1. Do not make the mistake of canceling these out, okay? Because there's a variable inside here, it's not just a constant, you are possibly eliminating a solution by doing that. So the safer thing to do is to get everything on one side. So we're going to have sine x times cos x plus 1 minus the term from the other side, which is 3 cos x plus 1, right? That is equal to 0, right? So now we can factor out the common cos x plus 1. So in my first term, I'm going to be left with sine x, and in my second term, I'll be left with minus 3 cos x, right? So this is now uh, an equation that we can solve using the null property. The null property says if two things times together gives me 0, at least one of those things has to be 0. So either cos x plus 1 is equal to 0, or sine x minus 3 cos x is equal to 0. So these then become simpler equations for us to solve. Okay, so the first one we have cos of x is equal to negative 1. Okay, and we know that 1, 0, negative 1, those are special cosine values. Okay, so if we look at our normal cos graph, it only has a value of minus 1 once per period, and that is at 1. Okay, so this is 0, this is 90, this is then 180 degrees, right? So that means that x is equal to 180 degrees plus any number of periods. Okay, so k is some integer. Okay, I think I need to shrink this a bit. Okay, right. And then the alternative, maybe I'll do this in a different color, is that sine x minus 3 cos x is equal to 0. Okay, so let's see. With this one, it feels like we're going to need to turn this into a tan equation. So I need to move this to the other side. So we're going to have sine x is equal to positive 3 cos x. Now, I am going to do something that seems contradictory to what I just said a few moments ago. I said avoid dividing by an expression containing a variable because you might be eliminating a solution. So, specifically, when you must avoid doing that is if, so I think I said specifically though, avoid canceling, right? Avoid getting rid of the expression completely, right? Which is what would have happened over here if we divided by cos x plus 1 on both sides and then poof, this factor was just going to disappear. Now we're just going to be left with sin x is equal to 3 cos x, which would be this bit of the solution, and it would completely omit this solution, right? So by dividing by cos x here, we're not getting rid of the cos x completely, because what happens here is that sin x over cos x is actually equal to tan x, right? So the cos x is still in the picture, it's just present in a different form. I hope that makes sense. So this would now be tan x is, oh my goodness, don't give up on me, is equal to 3. So the cos x has disappeared from this side, fine, but it hasn't disappeared from the equation, right? It's still present inside the tan x. That is very important. So this we'll have to solve with our calculator. I don't even think I have my calculator open. Like, what manner of, I don't even know what I can call it. Can't even call it confidence. It's just delusion at this point. To not have a calculator open while doing trig. Anyway, so for this one, well, we're going to need to work out the inverse of tan of 3. And because this is positive, the tan ratio is positive, so then we know that our answers are in quadrant 1 or quadrant 3, if you think about cast. And because it's tan, the period is 180, so we don't actually need to look at the two solutions separately. We can just look at the one and say, whatever that solution is, just keep adding 180 to that, and you will get more solutions. So we have inverse of tan of 3 plus however many periods we want, and k is an elemental. All right, so if we work out what that is, inverse of tan of 3 is, I think department does, well, I think it's one, what? One decimal place. Okay. So these would then be our two solutions. Oh no, what am I doing? Oh, go away, calculator. So we've got x is equal to 180 plus however many periods, or x is around about 71.6 degrees plus k180. And of course, the wise thing to do in your exam is to just take a sample of your solution set and put it into the original equation. Let's see what you get. So from this one, I'll take 180 plus, where's my calculator when I need it? And I really did get rid of it. Oh, dear heavens. Okay. Okay, so let's see. I'm somewhere going to take this one and add, how many 180s do you want to add? Maybe I'll do a negative number of 180s, and I'll take 8 of them, negative 8 of them. So let's say an angle like negative 1368.4, whatever. If I now take this number, I'm just going to store it for ease of access. How do I store again? Shift store A. Okay. So now I just need to put it inside the original equation. I hope it's sort of visible, as squished as it is up there. Can I start again, guys? Okay, cool. So we've got sine of, I should have actually put it in a box called x. That would have been great. Okay, is the alpha or no off? I don't know. Right, sine of A times cos of A plus sine of A. So that gives us 1,248, etc. Now we need to see if the other side will also give us the same result. So 3 cos squared x is just the same as 3 of cos x squared. So that will be 3 times the square of cos plus 3 times cos of A. And let's see what we get there. So we see that on both sides of the equation, we're ending up with the same value. So that's promising. So then let's look at this solution and see if we also get the same result on both sides of the equation using an angle from this solution set. So let's decide what we're going to use. I'm going to say 180 plus how many periods shall we add? Maybe let's add 25 just to be super frisky and to make our calculator work unnecessarily hard. Okay, so we're going to use 9,180. This time I'm actually going to put it inside x. Okay, so we've got sine x times cos x plus sine x. So that gives us 0. Nice. So now on the other side, do we get the same thing? 3 times cos of x squared plus 3 times cos x. And we do indeed get 0. So we are feeling very confident now that we have nailed this. Let's have a look and see what the memo has to say. So the memo, we are on par. Let's see if our answers match and then we can inspect how they went about solving. So they do get the same answers as we did. I rounded off to 1 decimal place. They're using 2. My bad. So they just use factorizing by grouping. So instead of factorizing each side individually, they first moved these terms over to this side and then they factorized using grouping, which effectively would have looked pretty much the same as what we did here. So potato, potato. Thank you for joining us for this chat and catch you another time for another ramble. Sharp.